Welcome to Calculus 3. This is section 13.5 in the ApexCalculus textbook. This video is part 2 of 2 with surface area examples. So for our first example, let's set up the surface area integral for f of xy equals 1 over quantity e to the x squared plus 1 over the region defined by x equals -5 to 5 and y equals 0 to 1. This is the image shown on the left here. We have a nice little rectangle that is defined in our region here. We see our function has kind of a little hump in the middle of this surface here. So as we're setting up our region, we see that polar conversion to any other coordinate system is not necessary. So f sub x, when we do our optimization here, or excuse me, our derivation here, if we rewrite our derivative as a power rule, you can see this is -e to the x squared plus 1 times the quantity e to the x squared times 2x using our chain rule, which this looks like -2x e to the x squared divided by e to the x squared plus 1. So our integral looks like 0 to 1, -5 to 5, the square root of 1 plus -2x e to the x squared all over e to the x squared plus 1, all the quantity squared. I think I dropped a squared -2. So that should be squared here, plus 0, there's no derivative with respect to y, times dx dy. And so this we've set up the integral. Again, this is not something that we would want to necessarily solve by hand. However, technology would help us solve it. So again, let's do another integral where it's easier to solve by hand. So let's suppose that we had the surface area of a function f of x, y equals x squared plus y over a triangle with boundaries y equals 2x, y equals 0, and x equals 2. So y equals 2x looks like this. Y equals 0 looks like this. And x equals 2 looks like this. So we know we have the point 2, 4. We have the point 0, 0, and we have the point 2, 0 as our boundary lines. So we know x is an element, or x ranges from 0 to 2. Y ranges from 0 to 2x if we're drawing our rectangles vertically in our region. So f sub x is equal to 2x, f sub y is equal to 1. So as we set up our integral, we go from 0 to 2, 0 to 2x. Notice that y must be on the inner integrand since y is a function of x. Take the square root of 1 plus fx, which is 2x squared, plus fy, which is 1, quantity squared, dy dx. Reducing this down and simplifying, we get the integral from 0 to 2 of the integral from 0 to 2x, the square root of 2 plus 4x squared, dy dx. So this becomes the integral from 0 to 2 of 2x square root of 2 plus 4x squared dx. So this is a nice u substitution problem because the derivative of u, if we let u equal 2 plus 4x squared, du is equal to 8x dx. So 1/4 du is equal to 2x dx. So then we have the integral of 1/4 square root of u du is our transformation here. So this, if we rewrite it as 1/4 u to the 1/2 du, we see this gets us 1/4 times 2/3 u to the 3/2, which we can then substitute back in our bounds. So we get 1/6 times 2 plus 4x squared raised to the 3/2 power, evaluated from 0 to 2. So doing our evaluation here, we see we get 1/6 times 2 plus 16 to the 3/2 minus 1/6 times 2 to the 3/2. Simplifying this, we get 1/6 times 18 to the 3/2 minus 2 to the 3/2. And you can simplify this if you'd like, or we can just leave it in exact form here. And so this is the surface area of that function over that region. As always, if you have any questions, feel free to let me know.